Hi, welcome to another video. So today I'm looking at this Mackie Thump TH12A. Got a 12-inch woofer. Now this thump was blown up. There was no bass or anything coming out of it. So this contour equalizer, high frequency, 12 kilohertz. Then the frequency range where you want the woofer and treble cut off. Then the mid-range and the low end 80 hertz, and then the volume control, and you can turn the equalizer on and off. That equalizer is controlled by a microcontroller and a DSP, so digital signal processor, and that's now obsolete, unavailable. And on this unit it's blown up, so you either scrap it or try and bodge it and get some sound out of it. So that's what I'm doing today. So these thumps, nothing like 1000 watt, because this power supply is just plus and minus 29 volts, and then you've got plus and minus 15 for the front end amplifiers with rectifier there, no PFC circuit, so just rectifying and smoothing the mains. Two little FETs down there for the switch mode power supply. As I explained the other day, there's a little chip under there with a metal top, and that's just screwed to the heatsink. That little chip is the bass output, rated at something like 240 watts RMS, into two channels. But Mackie take that chip, bridge it so it's one channel, and drive it into one woofer. And because it's class D and they're bridging the output, we've got two coils, so stopping the 400 kilohertz getting out onto the plus and minus of the woofer. So that's the bass, tiny little circuit, and a regular TDA 100 watt chip down there for the treble, the tweeter. So then we've got the mains filter, common mode chokes, stop the interference from the switch mode power supply getting back out onto the mains primarily. And this is what's left of the DSP. So the top circuit of this DSP, digital signal processor, is missing. The customer didn't send it back, but it's beyond repair. You can't get the EEPROM or anything, so the input comes here, as little as 50 millivolts, through a couple of op amps, then into a 24-bit encoder, which would then go up to the, either whether it's an FPGA or a custom sort of chip. Using a microcontroller, the waveforms are then shaped and then sent back down to this decoder, encoder, decoder, and then out onto some op amps. So the other week, just to get some sound out of this amp, I set up some resistors and capacitors. So through a capacitor and then resistor to ground, that's filtering the bass from the treble output, and then conversely using resistors and capacitors to ground to filter the treble from the woofer. Sent it back to the customer, said it's beyond repair, but you know, you'll get some sound out of it, have a try. That was a couple of weeks ago. Needless to say, it didn't work because it's back. So I've been struggling for a couple of days to get this simple little op amp in here to give me the desired frequency response for the bass. So most Mackie speakers that I've come across, they emphasize the bass, the bottom end, sort of 50 to 100 hertz, and then emphasize that portion, and then the rest after there just drops off. So with this speaker, I wanted to emphasize that bottom end, sort of 50 to 100 hertz, and then let this one chip, this is actually a dual op amp, but I'm just using one, let this one chip boost the bass and then drop off down to sort of 1 kilohertz where the tweeter takes over. I'll show you the circuit drawing. Now I put this all on the speaker, and every time I turned up the bass would cut out. So I thought I must be overdriving the bass chip. Every time I turned the bass up, I think we had something like 50 millivolts, maybe a bit more. Every time I turned the bass up, this little chip in there would cut out. I'd lose my bass and keep the treble. So I thought I must be overdriving it. So the digital signal processor, was obviously amplifying specific frequencies, which, like a computer control can do, just amplify very few frequencies and then let the rest be a flat response. Right, before I forget, because I usually forget to put something on a video. So this is a photograph I took to show the customer. This is Mackie's input board for the Thump 12A. I believe the 15s have got a similar setup. That's input amplifiers. This is a 24-bit stereo encoder decoder that encodes all the music as pure digital from here on. Comes up to this processor here, analog devices. Don't have the custom chips or specifically built for DSP. Yeah, Mackie aren't going to make them, so between this microcontroller here and this, all the frequencies and curves are tuned here for the bass, treble, roll-off frequency, and then the high end, then come back down, decoded, and come out as analog. And you can see here there's some pictures on the end of the old resistors and capacitors I had to filter the bass from the treble and treble from the bass. And the customer said they had no bass. Yeah, the treble was too loud. More on that in a minute. Bit of the data sheet for that. So it's a Wolfson 24-bit 192 kHz stereo codec with volume control. And if I flick down to the pin configuration, you see here it says analog in left, analog in right, and then voltage out left, voltage out right. So it goes in there up to that special chip and microcontroller, it's coded, and then comes back here. So all I did was bridged out the right to the right, left to the left, and it's presumably split for the bass and treble, because these aren't stereo. I can only imagine, yeah, they're split. One does the bass, one does the treble. This is the amplifier I've used in that circuit, LM1458 by Texas Instruments. So it's a dual op amp, but for cheapness and time I've just used this left hand side, and it is a split supply rail, so plus 15 and minus 15, because on all the Mackies that I've come across we've got a plus and minus 15 for the front end. And I have to say, most of these Mackie speakers, the front end is impressive. You can get full volume from 50-60 millivolts upwards, so 50 millivolts, yet you can still drive the input as high as 2, 3, 4, 5 volts. Right, so courtesy of some royalty-free music from Google, I'm going to turn this speaker on and put it through its spaces on this bottom end. There we go. So if I turn it down, if I pick another piece of music, now that amplifier chip has got overcurrent protection, so I thought there must be a fine line between driving it at max amplitude and too much current going to the speaker. But no matter what I did with the op amp, turning down the gain from like 10 or 15 down to 1, it still did that. Right, so here's that woofer. It's got Eminence, and I saw one of these on eBay in the box, and the box said Celestion. So whether the Eminence is made by Celestion or what, I don't know. Anyway, it's just a cheap, nasty thing from China. And hopefully you can see that's 8 ohms. 8 ohms. So you heard that amp cutting out at such a low volume, such a low amount of bass. So let's measure it without me getting my hands in the way. So here we are. So the meter measures 0.1. Hopefully the terminals are in view. Yes. 0.8 of an ohm. So it's been overdriven by some amateur and it's going short circuit. These don't just go short circuit, this must have been pounding, probably getting distorted, upsetting his audience or whatever. You know, unless of course he's got this in his own bedroom, then he's, you know, welcome to turn it up as much as he likes. But short circuit, 0.8 of an ohm, overdriving that amplifier. that's why the amplifier is going into current limit, because it's driving a short circuit. So if your Mackie Thump is starting to cut out like that, turn it off before it blows the amp, because this thump did need that amplifier chip. It was blew the chip and probably blew that front end, which isn't available anymore. Right, I've rigged up one of my monitor audio speakers. I'm that confident with the repair. Tidied up the amplifier a bit, turned down the gain. I'll put some Creative Commons music on, so royalty free, and give you a demo. Disconnect this speaker, you should just be able to hear the tweeter. I'll put this back on. So if you've got a blown Mackie, or specifically with that front end, the DSP blown up, don't have to throw it away. Get yourself an op amp, a couple of resistors, maybe a bit of board, stick it on there under the silver cover, screen it from the noise, make sure your woofer isn't short circuit. Hopefully this has helped. Thank you for watching.